apply some area formulas on some more complicated shapes, let me remind you of some of the formulas for the basic or the common shapes. For a square, recall that the area of a square will be equal to side length squared. Sometimes the motivation for calling this a square, actually that's the algebraic motivation for this geometric name. A rectangle, if we have a length L and a width W, we say that the area, or the area turns out to be, length times width. In a triangle, if we know that the base is B and the perpendicular height to the base is H, also called an altitude, then the area is 1/2 base times height. And finally, if we have a circle, we know that the area is pi r squared. Okay, so now let's take these formulas. If you don't have them memorized, write them down on a piece of scratch paper so we can refer to them. And now we're going to look at some advanced shapes or inscribed shapes. So this is my sad attempt at trying to draw a circle inscribed inside of a square. So that ovally looking thing in the middle, that's supposed to be a circle inscribed inside of what's, I hope, a good square there. And we're going to try to find the red region. So one key to doing these problems well is to recognize what shape is being added or subtracted from what other shape. So since this is a circle inside of a square and we're trying to find the remaining red part of the boundary, we will need to take a square formula and subtract from that a circle formula. We have a square shape minusing a circle shape. What was the formula for a square? Remember from the previous page, or hopefully now in your notes, side squared. What is the area of a circle? Well, from that other sheet, the area of a circle is pi r squared. Okay. Once we're to this stage, we can tell that what we're going to have to find is the square minus the circle. So now it's all about going into the picture and trying to find the values of these unknown letters or variables. So in particular, we have that the side length of the square is 18. So I can replace the side length with 18 in that part of the formula. For most of these problems in our homework, our textbook requires us to use the decimal approximation of 3.14 for pi, so I'm replacing pi with 3.14. And then for the radius is the distance from the center to the edge. So that would be half of the side length of the square. So since the square is 18, our radius will be half of 18, which is 9. So we put 9 there. So the answer is going to be 18 squared minus 3.14 times 9 squared. Now our textbook also allows us to use a calculator here, so that's all I did. You should pause the video and see if you are using the syntax on your calculator correctly. But if so, the answer should have come out to be 14.25. Oops, no it shouldn't have. The answer would have come out to be 69.66 yards squared. And it's squared yards because the units here were just straight up yards, and so when we do 2 dimensions, we're getting square yards. So, pause the video and see if you can find this shaded region. Assuming you took a moment out to try it, can you first answer what are the 2 regions that are being subtracted from each other? Well, it looks like it is a semicircle minus a triangle. So in terms of our basic formulas from the front page, there is an extra little wrinkle here that we only have half of a circle. Half of a circle. And that's being subtracted by that interior triangle. Okay, now what are our formulas? The formula for the circle was pi r squared, and the formula for the triangle was 1/2 base times height. So if we look at our diagram, we can see that this distance is labeled as 5. That's 5 millimeters, so that would be a height variable. And since that's a radius of the circle, that implies that the distance along the bottom here would have to be a total of 10, because it's 2 of these 5s. That's a 5 and that's a 5, similar to that 5, all being radiuses of the circle. So therefore, into the formulas that we have over here now on the side, we can go 1/2, pi gets replaced with 3.14, The radius from the diagram is 5 minus 1/2. The base is the entire distance across the bottom, and that's 10. And then the height is the 5. So that gives us our final answer. Again, pause the video and see if you can perform your calculator syntax correctly. But assuming that you do, the answer to this one should have come out to be 14.25 millimeters squared. Again, 2 dimensions, area, typically square units from whatever the one-dimensional measurements were in.